So today we're going to talk about the Zetta platform, but before getting there, for those of you that have missed it, we just made yet another announcement. So the 21st of June, we announced the Zetta platform, and today we announced a verticalization of the Zetta platform for automotive that we are developing along with TT Tech Auto. And this really takes the power of the Zetta platform that we'll be discovering through this webinar, combines it with time-sensitive networking and all the experience of TT Tech in automotive and in safety-critical software to provide to the automotive market a next-generation platform for really addressing software-defined vehicles. This will be the kind of architecture we'll be supporting. So Zetta Auto will support and supports, in fact, it's already available for evaluation, AutoSAR Classic, AutoSAR Adaptive, your favorite infotainment. It is, as we will see, the best probably solution for V2X. And you will have ASIL-D, so ISO 26262 ASIL-D certified stack from Q1 2024, because we are just finalizing the certification process. So this is the announcement. Again, Zetta Auto launched today. Early access is available, so reach us or reach TT Tech Auto if you want to put your hand on this verticalization of our Zetta platform toward automotive. And as you have perhaps get used to it, we couldn't resist, but we always celebrate things with a little cartoon, and so I'll let you just enjoy the cartoon of this partnership. And again, this is in a way what we are trying to do with Zetta Auto, which is put wings into next generation cars. And by the way, we are really working on some project on flying cars, as a matter of fact. Okay, so let's get back with our feet on the ground, and let's look into the Zetta platform. So let me quickly go back to try to understand what are the challenges that we are trying to solve as a company, because this is part of our mission, and as a consequence with our platform. So today, if you're trying to build any kind of system that spans from the data center down to the microcontroller, you know how it feels. It feels like this picture. It feels like assembling some kind of digital Frankenstein, stitching together more or less well heterogeneous technology, and I think keeping your finger crossed, trying to hop into some form of decent end-to-end semantics. That is true if you have to deal with moving data from a microcontroller to the data center, but then how about storage? How about computation? That's, again, more pains, more stitching, more digital Frankenstein for us to deal with. And many people seems to be living like in a Plato cave. I don't know if they are familiar with the allegory or the metaphor that Plato used to describe the human nature and the human existence, that sometimes, you exchange shadows for what is the real reality. But if someone decides then to step out the cave, and discover, what actually is possible out there, and then comes back, initially people think he's crazy. And this is what has happened a couple of times to us with our new technologies, right? Because people are so much used in, dealing and again, building system this way, that if you say, well, actually, the reason why you're having to stitch all these things together is because those technology were thought 30 years ago at the best, and the world has changed. There is a different way, and this different way, makes it much easier for you to build the system that we need to build today. At first, people, think you are kind of having hallucination, and then some people believe, and eventually more people believe, and eventually we get out of the cave. And so what are the technological challenges that we are trying to solve? Well, first and foremost is that of data and movement. Again, up to yesterday, there was no technology able to work efficiently from the data center down to the microcontroller. For those of you that are familiar with our Zeno protocol, you know that we have solved that problem with Zeno. On top of that, you have arbitrary topological constraints that are imposed by protocol like MQTT and its hub-and-spoke architecture, or by DDS with its completely flat architecture that makes it very hard to scale. You don't have support for mobility and very limited support for network-constrained transport or constrained networks and embedded nodes. if we look at data at rest, right, data at rest essentially remains a technological system that is location aware. So whenever I need to store data, I need to know where I'm storing data, because that's then the place where I need to get it back. But with decentralization, with the trend toward edge computing and cloud to thing continuum, there is more and more the need to decentralize this data storage. But if you decentralize data storage, then the question is, how can you actually issue a query without knowing where the data is? So that's one of the challenges. And the third axis, that is an axis that is universal in distributed computation, is again, if we have data flowing around or we store data, it's because we want to run computation on those. And usually you have several frameworks to deal with data in motion, from the data center down to the microcontroller, because before Zeno, none of those was able to span end-to-end. Then you use databases, and you have to integrate communication protocol databases by yourself in your application, and then you have to pick yet another framework to represent and trigger distributed computations, right? So those of you that are familiar with Zeno know that Zeno is a pub subquery protocol that actually unifies data in motion, data at rest, and computation from the tiniest microcontroller up to the data center. And it gives you location transparent abstraction, not just for PubSub, because that's typical, but also for data at rest and computation. So in Zeno, you can have distributed queries, which means that I can keep data stored wherever it makes sense in my system using my favorite databases. And in the case in which we don't have a plugin for that database, obviously we can develop, or you can easily develop a plugin for, as we will see, any database or protocol. And again, this ability of running a query that doesn't need to know where the data is makes it possible for you to keep data decentralized, and more importantly, for us to optimize the query depending on where you are on the network. So, but what are people talking about? What are people saying about Zeno? And I want to share some of, because again, as one of the co-author of the protocol, you might perceive me as being biased. And again, it's very hard for any of us to be completely unbiased. I honestly think Zeno is the greatest protocol, right? But again, as one of the co-author, would be strange for me to think as such. Although those that know me fairly well know that over time, right, I've been working on several protocols. And after 20 years, right, you say, that protocol was very good 20 years ago, but now we need something else, right? And that was, for instance, in my case, the path that I followed when on my work on DDS and then eventually moving to Zeno. But let's say what people are telling about this protocol. So last week, there was this one brilliant engineer that came to us in our forum and wrote precisely this sentence, which, I mean, it was Friday, I recall, because it had been a very intense week. I was quite tired, and this made my day. So he told us, whoops. What he wrote is that, it's very simple to go around and try things, and it's like a beautiful lake or sea during summer. Zeno calls you. I mean, if we can inspire with the technology this level of poetry into an engineer, I mean, I'm done, right? What else do I need? But obviously, there are other important information and perspective that are being shared recently on Zeno, such as this article from Amazon, in which it identified Zeno as perhaps the best protocol for IoT going forward, when identifying and analyzing the challenges and the limitation introduced by MQTT, MQP, DDS, and COPE. Or perhaps the ITU recognizing that Zeno is the best protocol for vehicle-to-vehicle communication, and in general, for what they define intelligent transport system communications. Or Open Robotics considering Zeno as a new hope for better communication. And by the way, as you know, Open Robotics has been using a protocol like DDS for 8 years. We were aware as a company of the problem that they would have encountered. And as I will make a point later on, 10 years ago, right, we were warning about those challenges. And you'll understand more of what we were doing 10 years ago in DDS later on, right? But I think that's an important point. So it's not a surprise that today Zeno addresses all those challenges, because those challenges we were pointing out them 10 years ago, saying that would have been challenges whenever people would have tried to apply DDS either to wireless network or to constrained network or to the internet. And again, we had we had that experience because we had been there, we had done that, and we had seen the consequences. I'll explain later on. And then yet more user that besides selecting Zenoh, because of its performance, scalability, and the fact that it can run on small and deliver very high performance, they made a very important point in their technical white paper in which say, well, we are a small innovative company. We wanted something that was easy to us to adopt quickly and to manage in a small team in a very agile manner. And the deceiving simplicity of Zenoh API made it possible compared to many other technology. So again, we are talking, it's about the Zetta platform, but as you can understand, at the core of the Zetta platform, there is Zenoh, right? Because it addresses all those problems. But we need to understand then what is left to do and the reason why we need the platform. So we're getting there. So for those of you that are not familiar to Zenoh, two or three more things so that you will have all the elements that are relevant for this webinar. And then there is far more information on our website. But again, Zenoh is written in Rust for security and performance. It sits, or it can sit on top of a data link. So for instance, we run Zenoh on serial. We run Zenoh on Bluetooth, OpenThreadX, on Unix socket, on shared memory. We have zero copy optimization. But you can run Zenoh on TCP/IP, on UDP, on QUIC, and so on and so forth. And we have API for your favorite programming language. So why Rust? Rust is receiving lots of good press recently, but we made the decision to move to Rust several years ago, where it wasn't such a popular language, but it was precisely for security. It was for security and expressiveness. So we knew the impact of memory management bugs and how they affect or open potential door for security. And that was one of the main reasons for us to move to Rust. Not the only, because the first version of Zenoh was still written in a memory-safe language and precisely in OCaml. And by the way, I would like to publicly congratulate to the OCaml community because they were just awarded with an ACM programming language award. And I think that's well-deserved because in terms of programming language research, they've done an incredible job. So congratulations to the OCaml community that in a way remains in our heart because the first version of Zenoh was indeed written in OCaml. Okay, Zenoh supports essentially any topology. You can do peer-to-peer in a full click, like you're used to doing DDS, but in Zenoh you can communicate over an arbitrary mesh. In Zenoh you can have clients that use peer as intermediate node to route their communication. This sounds very exotic, but it's very useful in platooning when you have robots, for instance, or in some V2X situation. We can have brokered, we can have routed communication, and all of this can be routed by software routers, which again are extremely lightweight. You can run those on a Raspberry Pi 2. Okay, Raspberry Pi 4 is a supercomputer for us. So you can run Zenoh on very small target. We have a C implementation currently for embedded systems, although if you look at our repository, you will notice that even in the Rust code base, there is an increasing portion of Zenoh. There is no STD, so targeting microcontrollers. So that's our long-term strategy as the Rust for embedded matures. But the key point is that our C implementation runs on Arduino, on Mbed, on Zephyr, QNX, you name it. It's MISRA C compliant. And by the way, this is one of the version that we are certifying ACLD. In terms of performance, Zenoh has incredible performance, and this is an independent study made by NTU. By the way, they've contributed to the Zenoh blog a couple of months ago, and you see that it delivers up to 70 gigabit per second on a 100 gigabit network, and has a latency of around 7 microseconds in the case of Peak, or 10 in the case of the Rust version. And it's extensible. So there is a plugin system that makes it very easy to plug transport, to plug protocols, and so on and so forth. So now that we have had a quick overview of Zenoh, right? Because Zenoh is the protocol that solves the challenges we're discussing about, data communication from the microcontroller to the data center, about data storage and communication. So the question is, why we have Zenoh? Why do we need Zeta? Okay, and what is Zeta? Well, the issue is that Zenoh is the technology that solves the problem, but then you have to do everything yourself. And some of our customers today are having to deploy Zenoh routers in the infrastructure. And usually this infrastructure spans from the cloud down to some device or some, let's say, premises. Could be a factory, or could be a tractor or a robot. And so this is painful. This is usually not your core business. And so we wanted to make sure that you could leverage the full power of our technology stack, but then without the pain of having to deal with the provisioning, the management, the monitoring, the scaling, and so on and so forth. Okay, and this is why we have launched Zetta. So Zetta is the first cloud-to-device continuum platform that leverages Zeno to unify communication, storage, and computation, once again, from the microcontroller up to the data center. It leverages Zeno to integrate seamlessly, as we will see, mainstream protocols and databases, and it's incredibly time, space, and energy efficient. And by the way, I've written quite a few articles on the hidden cost of communication in energetic sense. So we'll probably provide those. We have usually shared those as part of our newsletter. That's a good reason to join our newsletter. And if you search on our LinkedIn page, you typically will find the various articles that we have posted. There is another one coming up probably in a matter of weeks where I do literally a quantitative analysis of different protocols, analyzing all the different aspects that relate to energy consumption. I think that you will enjoy that quite a bit. Zetta is cloud independent. This is super important because, in a large-scale system, you might need to support different cloud, either because of regulatory compliance or because of countries. Like in Europe, in some state, you have a requirement that you have to run, let's say, on T-Mobile cloud or whatever. So having a solution that is bound just to a cloud provider, it's over-constraining for our customer. As such, from day one, we have built a technology that is completely cloud independent. And it's more than that, because you can mix and match cloud provider as you find useful. Okay, so that's quite important. The other point is that Zetta provides you with a single point of control to provision, manage, monitor your infrastructure on the cloud to things continuum. Okay, so you can deploy infrastructure on the cloud. If there is some form of edge, you can deploy on the edge, and you can deploy on premise. And the other important things, as you will see if you start using or if you get on the evaluation program, whenever you create a new project, right, we generate all a series of artifacts that make it trivial to then provision infrastructure on the edge or on premises and ensure that you have nothing to configure, right? You just do a Docker compose and you are done, because all the security is already pre-provisioned, pre-configured, all the certificates are generated. It's really zero touch, and that's extremely important, right? Because innovation should remove the number of steps that are required in order to do something, and you have understood that we are pretty serious on removing unnecessary steps. In terms of how the Zetta platform is organized, so we have the PaaS offering, right? So this allows you to provision, monitor, and manage our infrastructure from the data center down to whichever device is that you want to provision, right? There are the routers, the Zeno routers, all the connectors that you can provision on the various routers, and we will see what are the use cases that you can support with that, and then a rich set of monitoring tools. So not only you have the ability, as we have in part demonstrated during the launch, and we will in depth demonstrate during the next webinar, you have the ability of monitoring your infrastructure, visualizing all the application, visualizing the routing path, visualizing the number of messages per second, the bandwidth utilization, and so on and so forth. But you, with our plugin system, you are able, right, to load a tool, if available, for a given plugin. So in the case of DDS is one of the connector. You have a DDS subsystem that is part of your infrastructure and integrated with Zetta. Then by clicking on the connector, right, you will visualize the tool, and you will be able to do all the sort of things that you expect to do with a DDS tool. But on top of that, all the infrastructure will be leveraged. So all the Zeno tools, the fact that any of the protocols supported, as we will see, right? You can have a DDS application, an MQTT application, and a web application, and all of them talking together and talking even with native Zeno application transparently through our platform. So that's quite powerful. Okay, so in terms of connectors, we have connectors for MQTT, connectors for ROS, meaning ROS1. So if you have ROS1 robots and you need to do teleoperation, you need to do robot-to-robot communication, that's the place where you want to go. A ROS2 connector, which is based on our DDS connector, and recently we have added zero copy support to that, so that has become even more efficient. OPC UA, HTTP, and a few others. And then in terms of database plugin, we support RocksDB, MariaDB, InfluxDB, file system, main memory, S3, and once again, adding a plugin usually is at most 2 weeks of work. Okay, so that's quite straightforward. Okay, DDS, it's a special plugin for us. It's a first-class citizen in our platform because, as you know, ZettaScale is the project lead of the Eclipse Cyclone DDS, which is one of the most widely used DDS implementation, and for sure the most rapidly growing DDS implementation, right? Again, as such, we have some integration with Cyclone DDS that is better than with any other DDS vendor. Because, for instance, if you have our connector between Zeno and DDS uses zero copy, right? So you are not even crossing the communication stack to go from DDS to Zeno, and then you are into the Zeno network. This is quite useful, for instance, if you want to use a Zeno microcontroller, or once again, if you have your robot based on ROS2 using DDS, and then you want to do robot-to-robot communication using Zeno because of its efficiency over wireless network or its ability to scale to any network, then in that case, you're literally paying no overhead because from DDS to the Zeno bridge, it's zero copy. Okay, and then it's Zeno all of the sudden, all of the sudden, for the rest of the communication. So that's quite powerful. Okay, so with that in mind, I would like to cover a few use cases. So first of all, with our platform, right, you have an internet scale pub/sub platform that allows you to do peer-to-peer and transparently route communication across the internet, depending on where are the subscriber. So in this case, I have cars, those could be robots, could be anything, right? The interesting things of car and robots is that they move, and we have some specific support for mobility. And in this picture, I'm showing, for instance, some of our infrastructure deployed on 5G server. By the way, we have 5G integration already in place with some vendors that will be announced soon. But we're already experimenting on some factories in some robotics application with private 5G and Zeno integrated as part of the 5G. Zeno and the Zetta platform integrated as part of the 5G infrastructure. So in this case, you see, for instance, that there is a car that is under some duty cycle or not currently connected. So it's our infrastructure that keeps the data around. When the car wakes up, consume the data at its pace, and then eventually the data is garbage collected. You can use the same infrastructure, right, for distributed queries. And once again, the advantage of Zeta is that, from our portal, you see the entire system. You can decide which plugin to provision where, right? In this case, which storage, which data set each storage takes ownership for, the level of replication, the kind of database that you want behind, because it could be a RocksDB, could be a MariaDB, could be an InfluxDB. But then operationally, right, from anywhere on the network, you issue a query, and then there it's a Zeno protocol that decides, depending on where you are, what is or where is the optimal place to go and fetch the data and consolidate it back to you. So, in this case, if I was asking for some information on this side of the network, the car will be queried directly. But if I'm on the other side of the network and I'm still trying to get some information about this set of keys, then perhaps this cloud storage would be the closest place to get the data. Once again, why? Because Zeno resolves the query using routing strategies, and the routing strategies always try to optimize locality. Okay, so that's good for fault tolerance, it's good for load balancing. And by the way, you could start a new storage on the fly anywhere on the network. That storage is automatically aligned, and as soon as it is aligned, it will start serving queries that intersect with its data space, and thus, adding more bandwidth to your system and providing load balancing. Other important things: shell the system partition. We have an alignment protocol. By the way, the details of the alignment protocol are described on our Zenoh blog. And so eventually, as soon as the reconnection is established, all the storage will be realigned. Okay, but that's not all, because maybe you also want to represent computation. So suppose that I have a car that is moving around and it needs to get some information on some image, okay? So it could get, it could try to get this resource that is supposed to classify some image. And in this case, perhaps this is the queryable that is the closest to this car that can actually resolve this query. So a computation will be triggered and the result will be provided back to the car. If the car moves, same request, it's obviously triggered into a different queryable and resolved back. Once again, locality and mobility, right? And once again, this is essential to implement systems that scale and that are fault tolerant, because I can have multiple of these computation and use them for fault tolerance and for load balancing. And the fact that Zeta builds on Zeno, which is completely name-driven, makes it very easy to deal with fault tolerance and load balancing by replicating either storages or computations. And then, by the way, sometimes you need a little bit more articulated coordination. Be aware that in ZenoX, we have some distributed algorithm for leader election, for group management, and so on and so forth that can be used when you need to have a leader taking some specific actions. Okay, so let's look now at some use cases. And let's start with ROS. So let's imagine that you have robots, either based on ROS or ROS1 or ROS2, and you want to either teleoperate them, or perhaps you need to have robot-to-robot communication, and you're struggling with using DDS because it's blowing up your Wi-Fi. Okay, so this is a common use case that for which people are already using our Zenoh 2 DDS plugin. But now with the Zetta platform, right, you will be able to automatically provision routers, right, again on your favorite cloud provider, and perhaps down to the factory. In the case of the factory, it could be, for instance, a 5G server, right, where the antenna is running. And from anywhere on the network, because that's the other important things, right? The fact that Zenoh supports peer-to-peer mesh routed and, in fact, any kind of topology, make sure that if I'm sitting by the robot, I can communicate peer-to-peer with the robot. And if I have to do any monitoring, managing, the communication is local. The fact of the very rich set of topology that Zenoh supports makes sure that in this scenario, if the robots that are in the factory communicate with each other, this communication doesn't need to get to the cloud. I could even have some storages on my factory, and I never need to store data in the cloud. Yet, if I have an operator that is accessing the front end through the cloud, he can do a query, and that query is answered by the cloud. I don't know if you realize the importance of this, because many of the technology today that are used for this kind of system are hub and spoke. So they force you to go to the cloud, and then you get paid for traffic to the cloud, although the two robots were on the same factory. That's increasing your OPEX, right? And you could cut that OPEX. And this helps you reducing the OPEX because communication remains local if local has to be. Okay, so that's very important. Same things can happen with storage, and then you have manageability and access from anywhere. As far as you have a network connection, you have at your fingerprint the power of the platform with the guarantee that the communication will be as local as possible. So I'm in the factory, I will be able to communicate directly with the robot without the need to go to the cloud, and I'll be able to communicate direct to provision directly the robot without necessarily getting to the cloud. So that's quite important. And again, these are architecture that are already used in several robotics applications. Right, we have covered this in previous webinar, but we have several ROS-based applications that are used Zeno for R2X, and the Zetta platform will make it now trivial to scale this application to internet scale. Right, so that I'm really excited about this opportunity because we are providing next level support to our user, and I hope that they will be able to build a great application out of this stack that we are making available. Let's look now at DDS. And so let's take a deep breath here. So if we open a parenthesis in ROS, those of you that come from robotics probably know that the next version of ROS will be limiting DDS communication to the robot. Why? Because as it was presented even at the Zenoh meeting by the Open Robotics Foundation, people start using ROS, and usually they do through a Wi-Fi, and then they get in trouble because of DDS discovery overhead. And then they blame ROS, while the problem wasn't ROS, right? And so they are now actually constraining DDS communication to a single robot. So two robots won't be communicating off the shelf with each other unless you enable communication. And obviously, in our case, we will have an RMW that puts together Cyclone and Zenoh, right, with our plugin, and will allow us to use Zeno for R2X off the shelf to just simplify the life of robotics engineer. But let's go back 10 years and let's see what we were doing as individuals in a different company 10 years ago and the lesson that we learned. So there is a link on this page. And by the way, let me open the link because it's always better to see with your eyes. So as you see, this is a link on SlideShare. And this is from the 21st July of 2014. So I posted on July. So this is probably maybe from June. But let's say it was from July 2014, which is roughly 10 years ago. Okay. And that was obviously a presentation, which means that we were doing this sort of things we had been doing this sort of things for longer. So over 10 years ago, we built a product family called Vortex, in which we had an offering called Vortex Cloud. And as part of that product, we were the first and the only DDS vendor that were trying to scale DDS to the internet, okay? And the reality was that, it was like playing the contortionist. And I'll get a little bit more into the details. And the bottom line, right, for those of you that want to get the executive summary, was that there were really two choices. Either we keep the DDS semantics and we forget about scalability, or we get scalability and we break DDS semantics. But then in that case, you wonder, okay, so if in order to get scalability, I have to break DDS semantics, then what's the point of using DDS to go wider network, right? What's the point of using DDS when going through a wireless network? Right? Perhaps we keep DDS constrained to wired network where it works very well. And then for everything else, we do something else. And so back then, this used to be our platform offering, right? I used to be the CTO of PrismTech. And you see that we had JavaScript, DDS in JavaScript, a pure Java implementation, and we had this Vortex Cloud, okay? And by the way, if you look on the internet, we were doing interoperability demonstration with other vendors. They couldn't even figure out how we could do that, okay? Took them 10 years to figure out. And by the way, discovery service, routing service, whenever you see those names, go back to my slides 10 years ago. This is what we had in our product. Eventually, they figured out what we were doing, okay? And they built something that is not even as advanced as what we had. But again, why cannot DDS scale? There are some fundamental aspects in the protocol, and those of you that know where I've been, I know that protocol inside out, that cannot be made scale. So either you break those mechanisms and thus make it easier to scale, or you just cannot scale. So what are the problems? First and foremost is scalability, is reliability. In DDS, the reliability protocol is carried between every data writer and every data reader. You know what is the implication of that? The implication is that, imagine I want to build an open system. The amount of memory used by a data writer is impacted by the number of data readers that I have in a system. But by definition, in an open system, I have no clue of how many data readers there are. So either I break DDS reliability protocol and I give it a different semantics, or I forget about scalability and I forget about open system, because all of a sudden I cannot bound the amount of memory used on my data writer. And if that happens to be a microcontroller, I'm completely cooked. Okay, so that's already one example. Second point, discovery protocol just doesn't scale, because DDS works under this assumption that there is a completely flat system and everyone knows about everything. So you get yourself, especially if you're using extensible types, but in general, you get yourself with a quadratic problem in the number of participants times the number of readers, the number of writers, and the number of topics in your system. That's one of the reasons why it doesn't scale. Any new application that arrives and everyone, boom, sends on the network the discovery information. That's usually what let the network, especially wireless network, choke. The liveness protocol is another problem. And many of these aspects are exposed into the API and are used by application. So if you break the semantics, all of a sudden you have application that might communicate with local DDS application and DDS application that happen to be on the other side of the internet that don't have the same semantics. So that gets kind of tricky. And the question is, why bother, right? And this is our point of reflection. We went through the pain, we did it, it's deployed, right? So, and Buddy said, man, we can do better than that, right? I mean, why playing the contortionist? Why don't we come up with a protocol, right, that addresses all those problems and goes beyond? Because DDS only deals with data in motion. In Zeno, we deal with data address and computation. And this is one of the reasons why we did Zeno. And again, all of this is documented, and many of those of you that have followed me are very aware of what happened, but we were raising this red flag and nobody cared. And I think that proves that we are always transparent. We are for innovation. We are for solving problem. When there is a problem, we look at you in the eyes and say, that's a problem that's going to bite us in the future. And this is the solution we propose. That's ZettaScale, okay? Because, you know, in the end, we are a geek. We love great technology, and we can't live if we know that there is a limitation. We just have to get rid of the limitation. This is what we've done. And so, in short, to summarize, scaling DDS is the same as breaking its semantics, but most of DDS vendors today, I mean, they are just, you know, telling you that now they have a cool solution, which, by the way, I mean, we did over 10 years ago. And again, all the information is there. There are even webinar and, I don't know, hundreds and hundreds of slides from myself. So that's history. And thanks God, you know, the internet has good memory. And when the internet doesn't have good memory, or, you know, suppose that some site should disappear, then there is the Wayback Machine where you can go and find that information. So how do we solve the problem that we have in DDS? Well, with Zeno. Okay, that's also one of the reasons why we did Zeno. And Zeno can help you, again, to reach microcontrollers, right? Because all of a sudden, DDS, and again, this is something else where you have to be very careful, because there are some vendors that advertise they have DDS for microcontrollers. And then you look at it, non-standard API and non-standard wire protocol. There is an interoperable subset, sure. That's, well, you think what you think. And by the way, even in certification, be careful, because lots of people say, we've certified DDS. Well, look at the C++ API. Are those standard API? Perhaps those are not certifiable. So some people hide behind standard tag. We, you know, show off our innovation, and we think that's the most important. Open source and innovative, that's ZettaScale, okay? So once again, getting back to how you scale DDS, right? You can use our Zenoh connector, and all of a sudden, you can have Zenoh used across wireless network, across the internet, and you can use Zenoh on constrained portion of your system and have it interoperate seamlessly with DDS application. We've demonstrated this, I don't know, many times, right? You can have DDS, Zenoh, DDS, you can have Zenoh, then some routers if you're crossing the internet, and DDS, and it works like a charm. We have demonstrated how to teleoperate cars, or, I mean, the India Autonomous Challenge, that's how it was working, or robot teleoperation works that way. Okay, as we're talking about scaling, let's see how we can scale also MQTT. So what is the problem that MQTT has? Well, MQTT is a very successful protocol, but it has an hub and spoke topology. That means that you have to put these brokers somewhere, and it has to be in a place that is a place of rendezvous, because that's where you have to connect in order to communicate with other MQTT application. And so this in itself poses some scalability issues and some latency issue, because most of the time this broker is on the cloud. But more importantly, if I'm trying now to have some edge computation, the question is, where do I put the broker? Right? Do I put it on the edge and then have cloud application having to connect to an edge? But maybe I cannot, from the cloud, I cannot connect to the edge because I can only go out. I mean, it gets very messy very quickly, okay? And that's a consequence of the hub and spoke architecture. The good news is that Zeno has a plugin for MQTT, and now you can use the Zetta platform to provision your Zeta, our Zeno routers, and provision a strategic point MQTT plugin, which are MQTT brokers. And so now all of a sudden you can have brokers wherever you want in the network. The data between these brokers is automatically routed by Zeno, and you can have MQTT application talking natively with Zeno application, so that if going forward you want to use Zeno, you can mix and match, or you can continue to use MQTT because perhaps this is what your developer know. But now you have immense flexibility at a topological level and an entire platform that supports you in deployment, provisioning, and management. So very powerful. And again, this is true for any other of the plugin that we support. By the way, something else that is quite slick is that all of a sudden you want to do record and replay for MQTT application. You do this, you provision an InfluxDB, done, you are recording. And then playing back is just a query. So powerful. And again, we have demonstrated some of these aspects, for instance, in some of our robotics webinar. Okay, so concluding. I mean, as a company, there is only one thing that we can do. And I think as individuals, right, it's moving forward. Because in life, we are always student, never master. So we should never stop. Because the moment in which you stop and you stop learning and you stop having the student attitude, I mean, life becomes uninteresting. And so we keep moving forward. We keep moving forward toward making the development, the deployment, the operation of systems that want to span or need to span from the cloud to microcontroller easier than it has ever been. So this is our mission. This is our commitment. This is what we work very hard in order to achieve. And again, Zeta is today the first platform, right, that not only is based on groundbreaking technology like Zeno, not only integrates mainstream protocol to make it very easy to leverage this very strong, building block that is Zeno, and then operationally through Zeta, make it very convenient, right, to deploy, to provision, to monitor and manage this very large scale infrastructure, which indeed it's quite of a complicated endeavor. So thank you very much for your attention. I'm going to check questions, but if you had any question, please don't hesitate to, and you've not done so, don't hesitate to post them in the chat. Okay, so there is a first question asking how you can get your hand on the Zeta platform. So what you have to do is to send an email at contact, I'm writing it on the chat, at ZettaScale.tech. And we will reach out, because as of today, we have a limited number of evaluations that we are going to allow. There are still a few seats available, so reach out quickly. And then we will have the general availability of the Zeta platform in September. Okay, but we will keep posted, all of you. The reason why we are doing this is because we wanted to have a chance to have few selected company engage with us, trial our platform, give us feedback, that will, in our, as we always do, internalize to try to bring you a technology that is even more fit to your needs, and then do a general availability release in September. Okay, so there is another question concerning the commercial model of the Zeta platform. So there are really two commercial models for the Zeta platform. Pay as you go, like any other pass. And there it's even interesting because if you think about the fact that now you can deploy your infrastructure on the edge, and the fact that perhaps the edge is on your factory or you own that edge, all of a sudden, lots of the OPEX that you used to have, it's kind of gone, right? You just have a smaller OPEX, which is, the pay-as-you-go, monthly pay-as-you-go of the service that they're using from our Zetta platform. So that's one point. So pay-as-you-go, it's the traditional pay-as-you-go, and then there are various different ways in which you can optimize your OPEX that are allowed by our technological aspect and features. And the second commercial model is OEM. So if you're interested, you can literally OEM our platform, either white label it or deploy it on-prem. I don't see any other questions. Okay, so then thank you for attending our webinar. As I mentioned, next time, so 1 week from now, it will be live demonstration of the Zetta platform. So you will be able to see actually how easy it is to, again, start up a project and to start deploying infrastructure from the cloud down to the microcontroller. And then on the 21st, we will have a guest speaker with me. So Salva Rodriguez from TT Tech will be co-hosting a webinar on Zeta Auto along with me. So thank you again for attending, and see you next week. Take care. Bye.